Right. Now we are going to learn the motion of a helicopter. Okay. When I say motion of a helicopter, I'll try to explain everything from the taking off to the motion, the circular motion, everything. Because your seniors, grade 13 first term paper, they grade 13 first term paper, the last paper, I think was just 1 month back. One entire essay question was about helicopter. So say motion of a helicopter. Motion of a helicopter. Right. Under that, we are going to learn three categories. First category is taking off. Taking off means it will be at rest and a helicopter will start moving upwards. So first, I think we have to understand how it happens in the form of a figure. Now, helicopter has two rotors. You must have noticed it has two fans or two rotors. One is the one I've drawn here. It will be like this. Okay, so this is our rotor. Will be. There will be blades. I'm drawing the blades, and this view. Like this. So it will rotate maybe this way. When it rotates, we don't really worry about the speed at which it rotates. What we worry about the speed at which it pushes the air down. That is our concern. So I'll draw a rough body of the helicopter. We all know helicopter's body will be like this. Okay. Why does the helicopter's front part have a shape like this? That we will learn a little later. And at the same time, there will be another rotor here, people, a small rotor that is very essential. Without the small rotor, the helicopter cannot actually move properly without the small rotor. It's very important. The small rotor is very, very important. Right. I'll briefly explain the importance of that rotor as well. So we'll have the small rotor which will be rotating like this. Oh, come on. Sure. Like this, it will also rotate. So it might rotate clockwise. Can't surely say. I'll just say this. Okay, it also will rotate. Now, the large rotor, what it will do is it will push the air down. It will push the air down like this at a certain speed. It will push the air down at a certain speed like this. Do you agree with me? Okay, how does it happen? Just stand below a ceiling fan. When you stand below a ceiling fan, you will you will be able to feel a gush of wind coming towards you. Correct? Right. So then we have to think of the cylindrical a cylinder of air below that wing, below the blades. Okay, a cylinder of air below the blades. That cylinder is actually pushed downwards. No, people. That cylinder is pushed downwards. So when the cylinder is pushed downwards, as the now wait, I think I forgot to name them. This is the large fan, or sometimes we'll call it a rotor. This is a small fan or rotor. Okay, right. So what is this V? Let's describe V. V is speed at which air is pushed downwards by large rotor. That is that V. Okay, it's not the velocity of at which it's tangent. It's not tangential velocity. Yeah. The small fan is going to rotate along the horizontal direction. This is going to rotate along the vertical axis. So the axis for the large fan is going to be vertical. Axis for the small fan is going to be horizontal. Right. Now Right. So I'll consider this cross-sectional area here. This is the, let's say this is the cross-sectional area of air pushed downwards. This is, I'll take it as capital A. Capital A is cross-sectional area of air column pushed downwards. Push downwards. Right. Okay. Already. Then let me quickly describe how the motion happens. So as the large rotor rotates, it pushes an air column in the downward direction. According to Newton's third law, what will happen? Newton's third law, according to Newton's third law, air column exerts a force, force of equal magnitude, force of same magnitude in the upward direction. What do you call this force? Anybody? What do you call this force? Direction. This force is the lift force. This force is the lift force, or sometimes they call it, do they call it the thrust force? Yeah, sometimes they call it the thrust force. Also, what I'll say, it's getting lifted off now, people. This force is called the lift force. Force is called lift force. So I think now, since we have described the lift force, we can actually mark the lift force on this diagram. What do you think is the equation for the lift force, people? So there will be a force like this upwards, that is the lift force, and there will be a weight downwards, right? The helicopter will have a weight, don't forget that, to the mg downwards. So these are the two forces which will be governing the helicopter, right? Okay, this time initially the air was at rest, no, people. Air was at rest initially. Suddenly when the rotor starts rotating, air got the velocity. So what equation can I use without hesitating this time? A squared rho, yes, A squared rho. Since I can say, since air is at rest initially, and it suddenly acquires a speed, and it suddenly acquires a velocity as rotor rotates. What can I say? F lift is going to be AV squared rho. And forgot to mention, what is rho here, people? What is rho here? Rho is going to be density of who this time? Density of air. I told you these equations we are learning the, right? No, F lift is the force which is given by air to the helicopter. Resultant force is only F lift minus mg, Zainab. Okay, so they will ask the question this way. Hence, they'll say this, okay, hence, for the helicopter to just take off, what is the condition, tell me? If you want the helicopter to just take off, what is the condition? Anybody? A helicopter is not going up, but it's getting ready to go up. It's almost at the verge of going up. What is the condition? Yeah, very good. Yes. For the helicopter to just take off, the upward force must be equal to the downward force. So the upward force is the lift force, and downward force is mg. Okay, so the upward force, we can say av squared rho equals to mg. Sometimes they will ask us to find the velocity, so I can say v squared is equal to mg over a rho, which means v is equal to root of mg over a rho. Okay, people, root of mg over a rho. That's how it happens. Yeah, tilted rotor, then only it can push the air downwards now, Vasha. That's why the corner will be slightly tilted, no? The corner will be slightly tilted, I know. Yes. Then only it will be able to push the air down. Check your ceiling fans. In your ceiling fans, if you notice from the side, you will be able to see it will be like this, and there will be a slight bend like this in the corner. Have you noticed that? If I draw the ceiling fan, these are the ceiling fan is going to be, and the blades will have a slight indentation like this. That's to push the air down as it rotates. Otherwise, if it is perfectly flat, it can't push the air down. That's why the rotor is also slightly tilted. Avash, I hope it made sense. Okay, right. So this is the equation, people, and here rho is density of air, m is the mass of helicopter. Forgot to highlight that. M is mass of helicopter. And A can also be considered as the cross area of the fan, total area of the fan. Okay, that is that. Fine. Now this is when the helicopter is about to take off. When the helicopter is about to take off, and wait a minute, people. Wait. Yeah, column pushed downwards. Right. Now I'll quickly brief you about the small rotor. So how can I connect the velocity with the height of the air column? No need to connect the height to height. We don't know we don't know what height of air column is being pushed down. So we don't have to bring the height of air column into the equation here. It's not necessary. So we don't have to bother about what height of air column is pushed downwards. It's just the force. So let's not go there. No, okay. Right. Now, people, why do you think is the small rotor is there? Why do you think is the small rotor? Oh, this is fan. I don't know whether it's clear to you. Fan. What I've written there is fan. Small fan or rotor. Why do you think we have that small fan? No, not to make the helicopter move horizontally. No. If you want the helicopter to move horizontally, it needs to do something else. Thus, now listen to me very carefully. Yeah? At the beginning, the helicopter will be at rest. At the beginning, the helicopter will be at rest. What is it? What is the angular momentum of the system? The helicopter is at rest, no, people, initially. So what is the angular momentum? 0. Suddenly the rotor is rotating. So in the clockwise direction or anti-clockwise direction, I think it's clockwise direction, there is a angular momentum created. So initial angular momentum was 0. Suddenly the fan is rotating clockwise. Then what will the body try to do? The body of the helicopter. What will the body of the helicopter try to do, people? To conserve the momentum, it will try to rotate in the opposite direction. Which one? The body. The body will try to rotate in the opposite direction. When the fan try to rotate this way, the body here will try to rotate this way to balance that momentum. Do you understand? Why will it try to balance the momentum? Because initial momentum is 0. So this rotor, what we do is, now when the rotor rotates clockwise, the body of the helicopter will try to rotate counterclockwise. When this rotor rotates, which rotor? This small rotor, which is in the vertical plane, when that rotates, we will push the air in the opposite direction so that we will not allow the helicopter to rotate in that direction. I mean, now imagine if the front part of helicopter tries to rotate the other way. I mean, if it tries to rotate counterclockwise, If this can push the air towards us and create more torque in the opposite direction, this fan, then it can prevent the body of the helicopter from rotating. If not, what will happen when the helicopter goes up? Fan will rotate in one direction, the body will rotate in one direction. And imagine the people who are in the helicopter. They'll be, it's not how a helicopter should go, right? Helicopter should be straight when it goes forward or anywhere. It can't rotate. Only its fan should rotate. Only its fan should rotate. So I think I'll try to put a 3D diagram to help you understand it. Wait a minute. I think a 3D diagram will help you understand it better. Okay. 3D drawing. This is going to be very challenging. Wait, people. Right. This is the helicopter. Hold on. Yeah. To balance the moment. Yes. To balance the moment. That's exactly what's happening there. Wait a minute. I think the 3D diagram will help you understand it better, people. All right. Wow. Okay. Look at the helicopter now. Does this diagram make sense to you? I hope it does. Come on. Right now, I think you will be able to understand it much better. People, this is the rotor. Now the rotor is rotating. Okay, the rotor is rotating now. How? The rotor is rotating this way. The rotor is rotating this way. When the rotor rotates that way, to balance the angular momentum, the body will attempt to rotate the other way, this way. Do you understand? Rotor is rotating this way to balance, to make. Now initially angular momentum is 0. I think I will copy this to the next page and take it. Hold on. I think we are digging a little too deep here, people. Come on, because I don't want to waste time for these small things. Right. Okay. I will say direction of rotation of direction of rotation of large fan. Then this is what have I marked in broken lines and arrow? This is the body of helicopter. The body of helicopter attempts, and it will not rotate. Attempts to rotate to maintain total angular momentum 0. So now what will happen is our small rotor here will rotate. Small rotor will rotate in a way such that it pushes the air. Now it's trying to rotate counterclockwise now. So this small rotor will push the air that way, this way. This is how the air will be pushed by the small rotor. Air will be pushed this way by the small rotor. Okay. Direction of air pushed by small rotor. Direction of air pushed by small rotor. People, if the small rotor pushes the air that way, what will air do to small rotor? According to Newton's third law, what will air do to small rotor, people? It will push the rotor in the opposite direction. Very good, right? So I'll use another color for that. Then this way. This is direction in which direction of force, I'll say, direction of force exerted by air on small rotor. And you can clearly see that there will be a torque created by that force now, people. This force, and that torque will be opposing this rotation, correct? That force will be opposing the rotation. If your friend is trying to go towards right side, if you want to stop your friend from moving, you have to pull her or pull him back to the left side. No? Your friend is trying to run to the right, but you want to catch that person and pull them to the and stop them. If you want to stop that person from moving, you should pull that person in the opposite direction. Got my point? Same thing is happening here. Same thing is happening here. Okay, so I'll say direction of force exerted by air on small rotor. The torque created by this force, stops the body from rotating. Okay, yeah, this is interesting, isn't it? I don't know whether you have watched in movies and all. People sometimes, when there will be a helicopter and people in the ground will shoot the helicopter. When this small rotor breaks, what will happen? The helicopter will start making circles. It will swirl and go down, and it will, it will fall down. Have you seen? Have you seen that? The helicopter will lose its stability. How many of you have watched that? Maybe in movies or in probably in movies. Yes. Yeah, especially in military movies and all that happens. Yeah, now it makes sense, right? Everything can be explained using physics. That's what happens. So this small rotor is very important for the stability of the helicopter. Without that, helicopter cannot sustain its motion. Right. Okay, the diagram also came out really well. I think that is more than enough, people. Right. So this is okay. Importance of small rotor to maintain stability. Say I'll put it as a note. Importance of small rotor to maintain stability. Right. That will we can't really say how the two fans are rotating, people. Now if the fan rotates clockwise, it's going to push the air down. So if this, oh yeah, clockwise. No, both the rotors should be in the same direction. Yeah, clockwise. No, clockwise. This large fan is rotating clockwise. Small one will be rotating like this. Then on it will be pushing the air out. So air will be pushing it this way. Yes. But Zainab, I don't think they will go this far when it comes to A-level final papers. But in model papers, they ask these things. Okay, especially in Columbus school papers, they ask about these things. Better to know. But I don't think this was too complex for you to understand. Huh? Right, okay. Now, let me move on to the second topic. First was taking off. Second topic, now let's say helicopter is accelerating upwards. Okay. When helicopter accelerates upwards, what should happen? If you want the helicopter to accelerate upwards, what's the condition? I think that you should be able to answer now. If you want the helicopter to accelerate upwards, what is the condition, people? For the helicopter to accelerate upwards, lift force must be greater than mg. Exactly, lift force must be greater than mg. So maybe we can draw a rough diagram of the helicopter. Does it look like a helicopter or aeroplane? Okay. Right, okay, sorry. Helicopter is rotating and there will be a lift force and there will be mg. So mg will be acting downwards and the lift force will be acting upwards. And more importantly, the helicopter is going to have an acceleration in the upward direction. What is the equation we are going to use, people? I'll say A. So all you have to do is simple. First of all, F lift must be greater than mg. Then we have to say yes, upwards you can put F equals ma. So it is F lift minus mg Sorry. For F lift, what can I substitute now, people? Now you can see V is the speed at which AI is being pushed downwards. For F lift, what can I substitute? I can put AV squared rho. AV squared rho minus mg is equal to ma. I'll stop it here. I think they will give you acceleration and they will ask you to find v, or they will give you v and they will ask you to find acceleration. It will depend on the question. Let's not try by hearting these equations given according to the situation. Let's settle. Okay, right now helicopter can't keep going up, na people. Now when you go in a helicopter, we don't go to the moon, right? We have to go from a country or place to place, from Kandy to Colombo. So we will have to definitely move horizontally. How is the helicopter going to move horizontally? Please don't say it's because of the small rotor. No, small rotor has nothing to do with that. Small rotor is mainly for stability. If you want the helicopter to move forward rather horizontally, what should happen? Exactly. Next time when you watch a movie or a documentary where a helicopter is moving, watch closely how the helicopter looks when it moves forward. Okay. Yes. So the large rotor will be tilted. So that's a very interesting concept now. When helicopter moves horizontally. When helicopter moves horizontally, right, let's say if I can get the diagram right, wait a minute. I'm going to copy of this one. Paste it here and I'll rotate it a little bit, people. Right, perfect. Tell me, I need to change only one of these. What should be changed? Can someone tell me? One of them should be changed definitely, for sure. Who? Very good. Zuhra correct. Rima correct. Zainab Zanir correct. No. I think you have to make a small change to someone here. Very critical, very crucial, that one. Who? You can't draw MG like this, no, people. MG is always vertically downwards, remember. MG is always vertically downwards. F can be like that, no problem. F can be like that. F will be like, F should be like this actually. F should be like this. MG, no matter what you do, always downwards, remember. You have to always mark MG downwards. Alright, fine. This is the lift force. Wait a minute. This is the lift force, and yeah, AI is being pushed down at a velocity of v. No problem with that. This is the lift force. This is lift force, and they will definitely give you the angle. So see the force now. The play axis of the rotor. The axis of the rotor is creating a force now. Creating an angle. Because it's tilted, and we can control the helicopter that way, and when you tilt it, you are getting a force in what direction, people? You will be getting two components now, right? So there will be a component in the upward direction, that is F lift. What if this is theta? They'll give you those things in the paper, don't worry. F lift, or I'll just say F for the time being, people, because when I put lift and all, it gets a little complicated here unnecessarily. Let's just leave it F. So it's going to be F. What is the vertical component? F cos theta, and there is a horizontal component to make the helicopter move horizontally forward, F sin theta, and this time I should mark the acceleration there in this direction. Our helicopter is accelerating this way. Please, next time when you watch the movie, check it this way. Okay, good. So I'll just add a small note. For the helicopter to move forward, the large rotor must be tilted in order to create a horizontal component of force. In order to create a horizontal component of force. Right, people? Now I think just the diagram is not enough. We need to apply the equations and all. So tell me, we have to consider two equations here. What are they? Helicopter is moving horizontally, which means vertical forces must cancel out. Vertical forces must cancel out. So I'll say helicopter moves horizontally. So we know upward force must be balanced by downward force. What is the upward force here, people? F cos theta, that is going to be equal to mg. What is F then, people? F is going to be equal to mg over cos theta. Mg over cos theta. Next, what is the equation I should be using? Anyone? Next, we have to use horizontally in this direction. What force? What equation? Sorry. We have put F equals ma. So there's only one horizontal force, that is F sine theta, that is equal to ma, and instead of F you can put mg over cos theta into sine theta, and here let's assume that there is no resistive force. If there is a resistive force, you will have to subtract it, ma. Okay, people. You can cancel out m if you want, which ends where you end up in an equation like this: a is equal to g tan theta. No, people, g tan theta. Don't by heart, depending on the question. Okay, right. So I hope you understood this. Clear, people? Clear, everybody? Right. So this is the third case of helicopter. Now another point when it comes to a helicopter, still sometimes you might have seen, if you want to, let's say you are starting from a military base and then you are moving towards a target, and then for some reason you want to return, then how will the helicopter return? It will take a turn in the circular path. It will go like this and take a turn like this and come back. So in air, helicopter has to move along a circular path. So if we increase the upward lift force more, will it travel upwards or downwards? It obviously will travel upwards, no, Zuhra? Because mg is constant, right? Mg is constant downwards. So when F lift increases, its upward acceleration will keep increasing. So it should go up. I don't know why you think it might go down. Just ask you, why you thought it might go down? Because mg is constant. The total weight of the people and the helicopter, it will not change, right? So it is forwards and I didn't get you. Good question. Yeah. Okay. She's asking about this and this. Yeah. Then it's possible, no? If you increase F, people, what do you think will happen? If F is increased, then there will be a upward resultant force. They will not go that far, Zura, but it will be a little complicated, no? If you increase F, then your helicopter will go up as well as horizontal. So helicopter will go in this direction. I don't think they will test you that far. Horizontal, they will give you a constant force. Usually they give us a constant force. So we don't have to go to that extent. Right. Now let's move on to the fourth case. Fourth case, people, whether I will be able to draw it properly into, I'll try my best. Fourth case, helicopter performing circular motion. We just finished circular motion a few weeks back. Let's see if we can connect it. Helicopter performing circular motion. So no. Let me see if it works. Helicopter performing circular motion. I think I might be able to use this, right? This is the best diagram for that. Give me a second, but I have to tilt it as well. Let's hope for the best. Wait a minute. You're kidding me. Wait. Yep. Okay, perfect. Does this make sense, people? Now our helicopter, it's slanted. It's performing a circular motion, so I'll mark its path this way. Tell me if it makes sense to you. Right, this is the circular path. Does it make sense? Okay, right? Shape ne? It's going along a circular path like this. Maybe we can increase the arc a little bit more. Right, okay. So helicopter is taking a curve like this, and that curved path will have a radius. We call it the radius of curvature as usual. You can call it the radius of curvature from that to the center of that circle. Take that radius as r. Okay, and when it comes to the forces, mg will be acting downwards like this, and the lift force is still what? Lift force is slanted, because you can see the it's tilted. Who is tilted? The rotor is tilted. Mg will be down. Yes. So again, we can take the components, people. If this is theta, this is f cos theta, whereas the components towards the center, towards the what do you call that? Towards the towards the center of the circle is going to be f sine theta. F sine theta. So in order for it to move forward, the blades must always be tilted. Yeah. Must be tilted. Okay, so now it is performing circular motion, and for an object to perform circular motion, there must be a force towards the center, people. Right. So again, I'll start this way. Helicopter performs horizontal circular motion. So who and who should be 0? Helicopter performs horizontal circular motion. So who and who should be cancelled out? I mean, upward force component should be equal to downward force component. I think I have marked f cos theta incorrectly. Sorry. F cos theta must be marked vertically upwards, no? Like this, just to balance mg, so that I can balance mg. Sorry. F cos theta must be marked this way. Right. So f cos theta will be equal to mg once again. Then f is going to be equal to mg over cos theta. I think the way I marked the vertical component was incorrect. Right. Now tell me, who is the centripetal force this time? Who is the centripetal force? Who is the centripetal force, people? For circular motion of helicopter, everybody tell me, what is the centripetal force? Who is FCP? It is going to be not mg. Mg is downwards, no, not mg. F sine theta. Very good. Yes, F sine theta will be the force. Okay. So and we know FCP is in fact equal to mv squared over r. V squared means the velocity, tangential velocity of the helicopter, people, along this direction. How do I mark it? Mark it this way. Tangential velocity of the helicopter should be in this direction. Okay. Tangential velocity of the helicopters, that is v. Right, then let's substitute the values and finish it off. F sine theta will be, sorry, this will be F sine theta. F sine theta is equal to mv squared over capital R. For F sine theta, we can put mg over cos theta into sin theta equals to mv squared over r. So when who can be cancelled out, people? M and M will get cancelled out. Then finally, oh sorry, we are ending up in an equation g tan theta is equal to v squared over r. That's enough. According to the questions, you will adjust and do it. So when helicopter hovers, what does that mean? Hovers. What is the meaning of hovers? I have heard that word. Hover means yeah, obviously it's a horizontal circular motion. Helicopter is moving along horizontal. But hovers, I have heard the word hovers. What does it really mean? What does it actually mean? I'm not sure. Hovers or hovering. How does it? How would I know how it's pronounced? I've definitely heard that. Hover. Or to float in air. Hover means it is not moving anywhere. No. Hovers means it's floating in air. I just checked it in my dictionary. To float in the air. Hovering means floating in air. So there, Vasha, you will put like at rest. F equal mg. You'll put F equal mg. That's hovering. Right, people. Okay, let's not by heart these things, please. When you get questions, then you will be applying that accordingly. Okay, right. So I hope you all got an idea about the motion of helicopter. I think we have covered pretty much everything we need to know about the motion of a helicopter. So this must be okay. Alright, people. Hari. That's enough. It's like we have done a whole essay question here. Okay, right. Then we'll move on to the next topic. I think we spent a little too much time on helicopter, people. But okay, never mind. Let's quickly try a question on helicopter and see. I have a question. I'll share a question with you in the group. Maybe you can try that question. I think there was a question in the Colombo Royal paper, people. Wait. I think if I show that, I think we'll not do it now. I'll let you try it first. Okay, then we'll see. Grade 13. No, grade 12, grade 13. Colombo Royal 2012. Second term. Where is that? Just give me a second. Question is missing now, people. Thought I had it with me. 15 November. Yeah, perfect. 15 here. Yes. This question. Okay. Do you see the question, people? Is it visible, people? I hope it is. Yeah, okay. This is the question. This first page is entirely about the motion of a helicopter. So whatever we did today, you have to apply that theory and try this question. First you try it. Maybe we can discuss it later. I'll share it in the group. Right, let me take a screenshot immediately in front of your eyes. Okay, then I'll share it. This is the 2015 Colombo Royal grade 13 first term paper. It's a cool question, so you can try it. I'll post it in the group right away. Try it as homework. We'll discuss. Okay. Check the group. Once you get the question in the group, put a thumbs up that in the group. Okay, now I'll quick right. Once you get it in the group, just put a thumbs up to that in the group. Fine. Now let me quickly give you a question based on helicopter. Ready? a small question, or maybe, yeah, you can write the question and send the answers if you want. Up to you. Okay, let's quickly try this question, people, before we move on to the next main topic. Right, let's start. Helicopter of mass, well, start with me quickly, 1440 kilogram, is parked on the ground, surrounded by air of density 1.2 kilogram per meter cube. I put the 3 later. Right. The cross-section area of air swept downwards. The cross-sectional area of the air column swept downwards when the large rotor rotates was 30 meters squared. 30 meters squared. So let's ignore the upthrust acting on the helicopter. Ignore the upthrust. Upthrust means the V rho G, that. We just have to consider the lift force acquired by the helicopter. Right. Then under that I have a couple of questions for you. Roman 1. At what velocity must air below the fan should be pushed downwards? Downwards in order to just take off the helicopter. In order to just take off the helicopter. Okay, just in order to take off the helicopter. Right, number 2. It's wait. The helicopter is tilted by 10 degrees as it 10 degrees as it moves forward. What will be the acceleration? Okay, well, so yeah, these are the questions for you. Well, 30 meter kilogram per meter cube, yeah, meter minus 1, meter minus 1. Okay. No, density of air cannot be neglected. Density of air must be given. I haven't given you, sorry. Density of air 1.2 kilogram per meter cube. 1.2 kilo. It's given in the question. Yeah, it's given in the question. I'm sorry, I forgot. Density of air is given in the question, Avasha. 1.2 kilogram per meter cube. It's given. Horizontal circular motion. Okay, 4 questions for you. All 4 covered. Quick. So the 4 questions for you. Okay, people, what is happening? Right, good. I have 10 degree. Sorry. So third one, you will need more information. Third one, so extremely sorry about that, people. For third one, you take cos theta, cos 10. So sorry about it, I forgot, missed. Cos 10 degree, will take it as 0.98. Sin 10, we'll take it as 0.2. Sorry, very sorry about it. Forgot it. If not, yeah, okay. If not, no. Wait. We'll take it this way. You use the log table where the numbers somewhat close to this. Okay, so since you have done, I'm not going to change it. Okay, since we are running out of time, let me explain this then. Tan was 1.7. Okay, 0.18. Tan was okay. Tan. Okay. Tan 10. 0.18. Yeah, 0.18. We'll make it 0.18. Tan also almost same. Sin theta and tan theta will take equal. They will be almost equal. kilogram ko. Okay, let's start with the question now. Answer for part 1. At what velocity air below the fan must be pushed downwards in order to just take off the helicopter? Then we have the helicopter, and we want the helicopter to just take off. That's the case. mg must be balanced by lift force F. So F must be equal to mg, correct? For F, we know we can direct write the equation AV squared rho, that's equal to mg. Right, area 30, I see 30 meters squared. Area was 30 meters squared, so 30 into velocity we had to find v squared into density is 1.2. Mass is 1440 into 10. These are the numbers, correct? So I'm getting v squared equal to 144 into 100 divided by 13 to 1.2 is 36. So v will be a perfect answer because square root of everything. 12 is square root of 144, 10 is square root of 100, 6 is the square root of 36, which means answer I'm getting is exactly 20 meters per second. 20 meters per second. Okay, 20 meters per second for the first one. Looks like there was no issue in that. Most of you got it right, very good. And then if we go to the second one, Roman 2, now what is happening? Find the vertical acceleration of helicopter, right? Okay, now to find the vertical acceleration of helicopter, it's not necessary to draw the diagram every time, people. It's not necessary at all. Just drawing it for the sake of drawing it. Right, now again there will be a lift force, and there will be mg, and it is now moving upwards, if a, right? So the AI is being pushed downwards at a velocity of 90 kilometers per hour. That v is only given as 90 kilometers per hour. When you say 90 kilometers per hour, is equal to 90 times 5/18, which is actually 25 meters per second. AI is being pushed downwards at 25 meters per second. I hope I'm correct. So now for this particular scenario, we have to apply upwards F equal ma. So for upward resultant force is F minus mg equals ma. F is AV squared rho minus mg equals ma. Think it might be a little problematic. Let's say, okay, A 30, V squared is 25 into 25, density is 1.2 minus mg. 1440 into 10 equal to 1440 into A. Okay, people, what happened here? I think we can simplify everything by 1.2. When I simplify this by 1.2, here it will be 1200. Here also it will be 1200 because 12 into 12 is 144. And yes, so what will I get here? 13 to 25 into 25. 13 to 25 into 25. What is that going to be? 625 into 30. 625 into 30 is 625 into 30 is 1800 and this one 18,750 I think, minus 12,000. Correct me if I'm wrong. Equal to 12,000 A. So A is in fact equal to 6,750 over 1,200. So 675 over 120. 675 over 120 is 135 over 24. Is it? Which is 45 over 8. People, I'm getting 5.625 ms minus 2. 5.625. Yes, perfect. I'm getting 5.625 ms minus 2. I saw this answer from few of you. Yeah, 5.63 is the answer. 5.63. Okay, anybody else who got this answer? Should be 5.63. 45 by 8. Very simple, huh? Just applying F equal m and getting the answer. Just simplifications and all, you have to do it carefully. Good job. Now the helicopter is tilted 10 degree as it moves forward. If that's the case, it comes Roman 3. Now the helicopter is doing this tilted like this, and it's moving forward. Right. So there will be a force. The lift force will be acting like this. No, this time F, and the mg will be acting down. Since this is an essay question, you will have to show the steps. F. So this is that theta. This is F cos theta. The vertical component is F cos theta. Horizontal component is F sin theta. And the helicopter has an acceleration of A. And are they asking for that? Yeah, they're asking for that. So first of all, we know we can say upward force must be equal to downward force. Upward force is F cos theta, and the downward force is mg, which means F is equal to mg over cos theta. And now horizontally, when you apply F equal ma, horizontal force is F sin theta, that's all, equal to ma, m into A. For F sin theta, we can put mg over cos theta equal mg over cos theta into sin theta equals ma. Correct, people? And I think m and m will get cancelled out. So for A, I'm getting g tan theta. Did anyone get g tan theta for A? G tan theta? No. Should be g tan theta, right? Yes. Then g is 10. Tan theta I have given. Tan 10 is 0.18. So go to answer is 1.8 ms minus 1.8. The other I've taken roughly 1.8. Then that is another. This now this is about the other. So what was the motion? Assume that it is tilted in green, that's the same velocity. Okay, it should be mentioned in the question. Till 10, I guess the rising down as a Sorry. Guys, can you hear me now? Hello? Don't make it complicated. Zainab, let's not make it complicated. Let's do it this way, because if you substitute large values, it's unnecessary, too much work, right? Do it this way and try to get the simplest form, equation form for A, and then substitute the values and get the answer. Just so it will reduce the step now. Otherwise, if you try to substitute the value for F and get it, it's too much. Don't do that. Okay, then what was the answer for the fourth one? Anybody did that? Fourth question. Anybody? Okay, wait. Adnan had got an answer, right? What is the answer you got, Adnan? You have got 0.03125. 0.303125. That's a very small radius. It's like 3 centimeter radius. No? Practically, it's not possible then. I think my numbers are not so satisfying then. No? Seems like my numbers are not satisfying. Let's see. Roman 4. Now, there is a circular motion. We are supposed to find the radius. Roman 4. So our helicopter is moving along a circular path now. And it's tilted actually. Okay, it's tilted like this little. So force is not perfectly vertically created. Yeah. So this is how the vertical force is acting now. Sorry, lift force is acting now, which means mg will be acting downwards, and a component of this F will be acting towards the center, that is F sine 10, and F cos 10 will be acting upwards. Okay, yep. And the helicopter will be performing a circular motion. Be like this. People, am I audible? Hello? I hope I'm audible. And there will be the tangential velocity of 10 meters per second. Okay, right. So now horizontal circular motion. So what can I say? Upward force must be balancing out the downward force. Upward force as before, F cos 10. Downward force is mg. So F is equal to mg over cos 10. All right. And then for circular motion, let's go with centripetal force equals mv squared over r. Centripetal force is F sine 10 equal to m v squared over r, and instead of F as usual we can put mg over cos 10 equals to, mg over cos 10 into sine 10 equals to mv squared over r. Let's simplify that and get it in the simplest form possible. M and m will get cancelled out now, people. We are supposed to find out r, remember. So on the left side I have g tan 10. On the right side I have v squared over r, which means r is equal to v squared over g tan 10. Okay, g tan theta or g tan 10. This is what we are getting. So r is equal to v square is 10 into 10 into 1.8, no, not 1.8, I think it was 0.18, right? Tan 10, 0.18. So we are getting 10 and 10 will get cancelled down here, both are 10 on top and bottom. I'm getting 10 over 0.18. 10 over 0.18 is 100 over 1000 over 18. 500 over 9. So r is equal to 500 over 9, 5.556 meters. This is what I'm getting, Adnan. Your answer is a little too small, no? They are not practically possible. Anybody else who got this answer somewhat similar to this? Zaidam's answer is also too small. Now what happened? Adnan got 56 points. Okay, right. Avash has also got it. Good. Is it 56 points on or 55.7? So 55.6. Right. Okay. Then Zainab Zanir, what happened there? You have got 0.03125. That's Zainab Zanir's answer, no? Okay. Adnan has got 56.7. Yes. Some maybe division error, probably. Right. So here you simplify as much as you can and then you plug the values. Okay. Right. Okay. So we have almost done an essay question here. I've covered. We've almost covered everything here, right? Good. Fine then. So this is how you apply the concepts of Newton's second law for the motion of a helicopter. Right. Try the other question also and see how it goes. And right, next class we will be starting proper hydrodynamics questions. There is something called continuity theorem, and after that we will be learning about something called Bernoulli's theorem. After finishing those, then we are done. I don't think we'll be able to complete it within tomorrow. I'll try my best because there are certain cases we need to learn under Bernoulli's theorem. We'll try our best tomorrow. If not, definitely inshallah week after tomorrow, next week. Not tomorrow, next week, or week after next week we can finish. Not tomorrow, next week. I don't think we'll be able to finish. Probably week after next week. So week after next week, we might do half class theory, and then we can definitely try this. We can definitely try questions. Yeah, in the third and fourth, f is not equal to mg. No, f cos theta is only equal to mg. The third and fourth, f cos theta will be balancing out mg because f is not vertical. No? So vertical component of f will only balance mg because